Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem. So right here we have 5 to the power of 100 minus 5 to the power of 99. And also, make sure to stick to the end of the video because I have a couple bonus problems where you can apply the tricks I used solving this problem to solve those problems. Alright, so we have 5 to the power of 100 minus 5 to the power of 99. Now, 5 to the power of 100, well, we could rewrite this as, first off, 100 here. This is equal to 99 plus 1, right? Meaning 5 to the power of 100, I'm simply going to replace 100 with 99 plus 1. So this would be equal to 5 to the power of 99 plus 1. Then we have minus 5 to the power of 99. Now, an important property of exponents is that, let's say I have something in the form a to the power of m plus n. This is equal to a to the power of m times a to the power of n. So in this case, we have 5 to the power of 99 plus 1. In this case, a would be 5, m would be 99, and n would be 1. So we're going to rewrite 5 to the power of 99 plus 1 as a to the power of m, so 5 to the power of 99 times a to the power of n, so 5 to the power of 1. And we can't forget our 5 to the power of 99. Now, I'm simply going to factor out 5 to the power of 99 from this. So if I factor out 5 to the power of 99, I get 5 to the power of 99 times. Now 5 to the power of 99 divided by 5 to the power of 9, well, that's simply just 1. 5 to the power of 99 times 5 to the power of 1 divided by 5 to the power of 99, simply 5. And we have minus, now 5 to the power of 99 divided by 5 to the power of 99 is 1. So we have 5 to the power of 99 times 5 minus 1. And now this is equal to, we can simply simplify what's in the parentheses. 5 minus 1 is 4. So we have 5 to the power of 99 times 4. And this is our answer. Now, I'm going to be giving you guys a similar problem to this. And you guys should be able to solve this problem using the same tricks. So we have 2 to the power of 10 minus 2 to the power of 9. So I'm going to ask you guys to pause the video and try to solve this problem. Alright, so I'm assuming you guys tried to solve this problem. So what we're first going to do is, as you see here, we have our 10. Remember, 10 is equal to 9 plus 1. So now I'm going to replace this 10 with 9 plus 1. So now I have 2 to the power of 9 plus 1 minus 2 to the power of 9. Now, to simplify 2 to the power of 9 plus 1, I'm going to be using the property a to the power of m plus n is equal to a to the power of m times a to the power of n. Let me just rewrite that. A to the power of m plus n is equal to a to the power of m times a to the power of n. So for 2 to the power of 9 plus 1, we can think of a as 2, m as 9, and n as 1. So 2 to the power of 9 plus 1, this would be a to the power of m. So 2 to the power of 9 times a to the power of n. So 2 to the power of 1. Now we're subtracting 2 to the power of 9 from this. And now if we factor out 2 to the power of 9, we get 2 to the power of 9 times, now 2 to the power of 9 times 2 to the power of 1 divided by 2 to the power of 9, simply just 2 to the power of 1 minus 2 to the power of 9 divided by 2 to the power of 9 is 1. All right, so now we have 2 to the power of 9 times 2 to the power of 1 minus 1, and 2 to the power of 1 is the same thing as 2, so I have 2 minus 1. 2 minus 1 is obviously 1, so I have 2 to the power of 9 times 1, which is the same thing as 2 to the power of 9. Now I can actually go ahead and simplify this a little. Remember the property a to the power of m plus n is equal to a to the power of m times a to the power of n. Well, we can rewrite 2 to the power of 9 as 2 to the power of 4 plus 5. So this is going to equal 2 to the power of 4 times 2 to the power of 5. Now 2 to the power of 4, this is equal to 16 times 2 to the power of 5, this is going to equal 32. So I have 16 times 32. So let me quickly multiply these two. 2 times 6 is 12. We carry the 1. 6 times 3 is 18. 18 plus 1 is 19. Now we put our 0. 1 times 2 is 2. 1 times 3 is 3. So I have 192 plus 320. 2 plus 0 is 2. 9 plus 2 is 11. We carry the 1. 3 plus 1 is 4. 4 plus 1 is 5. So 512 is our answer to this problem. Now I have one final problem for you guys. So we have 2 to the power of 200 minus 2 to the power of 199. Let's see if you guys can solve this problem. So I'm going to ask you guys to pause the video and attempt to solve this problem. All right, so this is a pretty basic problem after applying the rules we already had. We have 2 to the power of 200 minus 2 to the power of 199. We can rewrite 200 as 199 plus 1. So now we have 2 to the power of 199 plus 1 minus 2 to the power of 199. And remember, if we have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. In this case, a is equal to 2, m is equal to 199, and n is equal to 1. So this would be equal to a to the power of m, so 2 to the power of 199, times a to the power of n, so 2 to the power of 1. We are subtracting 2 to the power of 199. Now if I factor out 2 to the power of 199 from this, I get 2 to the power of 199 times 2 to the power of 199 times 2 to the power of 1 divided by 2 to the power of 199 is simply 2 to the power of 1 minus simply 1. This is equal to 2 to the power of 199 times 2 to the power of 1 minus 1 is simply 2 minus 1, which is 1. And this means our answer is 2 to the power of 199. So you can actually use this trick for any problem, such as this one, where it's a to the power of m minus a to the power of m minus 1. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 2 to the power of x is equal to 0. Now what I'm first going to do is I'm going to take the log on both sides. So now I have log 2 to the power of x is equal to log 0. Now, if I have something in the form log a to the power of b, this is equal to b times log a, because I can actually move this exponent b to the front of the logarithm. So this is actually an important property of logarithms, and I'm going to use this property on log 2 to the power of x. So I'm going to simply move this x to the front of the logarithm. So now I would have x times log 2 is equal to log 0. Now we want to isolate x, obviously, so I'm going to divide both sides by log 2. So then these two cancel out, and I would have x is equal to log 0 over log 2. However, log 0 over log 2, this is equal to, first off, log 2 is equal to 0.301. However, log 0, this is actually undefined. Log 0 is undefined, meaning x is also undefined because you can't divide an undefined number over 0.0301. So this means that the value of x is undefined.